Hi all, welcome to this video recording. This is about assignment 4. In assignment 4, you'll be implementing a custom class for vectors. So you'll be implementing a class for vector data structure and like how it works for it works in the standard libraries, the vector. We won't be implementing it exactly the same way, but we'll be slightly modifying it so that it's easier for the assignment 4 purposes. And one of the important things that you should remember is that whatever the vector class that we'll be writing, this vector class is strictly for integer data type. So unlike the regular vectors that you use where you can create a vector of strings, float, etc., for this assignment, it's going to be strictly integers. And let's see the differences between like vectors and arrays and why vectors are popular. So let's say if I want to create an array of integers in C++, I'll go about doing this way. So the compiler, while the program is getting compiled, or whenever you do g++ main.cpp, so the moment you try to compile the code, then at that time, C++ compiler expects us to tell how many, how many elements will be there inside the array. So in this case, there will be 4 elements. So it goes and reserves 20 bytes of space, and that too continuous space for this array element. And the problem being with arrays is that while the program is running, that means whenever we are doing ./a.out or ./a.exe, we cannot expand this. Like what if when I'm running the program, I realize that I want to store more elements in this array. So this is not possible in C++. Arrays are fixed size and you cannot expand them. So to overcome this concept or to overcome this drawback, we have something called as vectors. And things happen at runtime. So that means whenever you are running the program, things happen at runtime, and vectors can automatically take more space in the computer's memory and try to and allows us to store more elements on demand. So that's the beauty of vectors. And to tell you all a quick example, if I want to create a vector of integers, I'll go about doing this. Let's say I want to create vector with 5 elements. So this means this is how the vector is going to look like. There will be 5 zeros, and these are the indices, and this is going to be my vector name, ARR. Now, let's say if I want to insert an element into this vector, I'll go about doing something like ARR dot pushback, and I'll insert 1. So now if you notice, there are already 5 elements in the vector, and we have requested for a vector with 5 elements only, and all of them are populated. So what happens in vectors is that if we are asking to insert new data, and if there is no space left, all the 5 slots are filled with zeros, then what will happen is whatever the size of the vector was, like 5 elements, 2 times the size would be allocated, or 2 times the capacity would be allocated. And as a result, vectors capacity would be now 10. 9. And already there are 5 zeros. And now we are asking the compiler or C++ to insert 1 into the vector. So always remember, there is something called as capacity in vectors. Let's say if I'm creating vector in this manner, vector of integers, and then name for the variable is ARR, and 5 is the size. So this is what we call as capacity of the vector. So the capacity of this vector, it's going to be 5. And now what happens is that if the number of elements in the vector, so the number of elements stored in the vector is what we call as size. And if the number of elements in the vector, in this case, all zeros. So if you're creating a vector in this manner, it's going to be all zeros in the 5 slots. So capacity is 5. That means vector can accommodate up to 5 elements. And size is 5. That means all the 5 elements are filled. So the moment if size and capacity are equal, and then what happens is that the programming language tries to find new block of memory, which is twice this capacity. So if the capacity is 5, the programming language tries to find, uh, you know, uh, storage block twice the capacity, and it creates the vector again. So we'll have a new vector, and now with since we are asking for one to be pushed back into the vector, one will be added in this position. Now, as a result, the updated values for capacity would be 10 because it's going to be 10 elements now, and size, it's going to be 6 because we have 6 elements filled in the vector. So this is how both the variables capacity and size are used. Size will tell us how many elements are there in the vector or how many elements are filled in the vector, and capacity will tell us how many elements can be accommodated in the vector. So using these two, like whenever size reaches the value of capacity, what we have to do is we have to find or create new memory block, and which is twice the capacity size. And then we have to copy the vector elements. So let me show you one more example. Like let's say I already have a vector called as ARR with, let's assume that I have 4 elements. So these are the elements and the indices too. So now at this point, the capacity of this vector, it's going to be 4, and size, it's going to be 4. That means this vector can hold up to 4 elements, and all the 4 elements are filled at the moment. Now, if I'm asking for a new element insertion using the function pushback, so let's say I want to insert 4. What needs to happen is that somewhere inside the computer's memory, so whatever the capacity is there, we have to allocate or ask for a space that's twice the capacity. So let's say a new space was found, which is twice the capacity. So 0, 1, 2, 3, 4, 5, 6, 7. Now our job is to, as soon as we allocate this memory, which is twice the capacity, we have to perform an operation called copying, because we have to transfer the elements in old memory block to new memory block. So these things should happen, and we'll be writing code for this copying as well. So copy 0 into 0th location, 1 into the first location, 2 into the second location, and 3 into the third location. Once you copy all these elements accordingly, now the task is to add an element 4 at the end. So this is how you add. So at this point, after the reallocation, it's going to be twice the capacity. So capacity is going to be 8. This vector ARR can hold up to 8 elements. And the size value, it's going to be 5. That means there are 5 elements in this vector. So whenever we are implementing vectors on our own, let's say that if size and capacity are equal, we'll be creating a new array twice the capacity, and then we'll be copying the contents. So remember these points. If at any point, whenever you're adding data, if size and capacity are the same, what we have to do is allocate new memory block twice the current capacity. So whatever the current capacity is there, we'll be asking for 2 times the storage space than the current capacity. And then another operation that we have to do is copy all the data from old memory location to new array. Okay, so these are the 2 steps that we have to take care of. And now a couple of quick points. So in this assignment, we'll be using something called as dynamic memory. So at any whenever the program is running, On demand, if you're asking for more space, that more space comes from this part of memory called as dynamic memory. And the way we deal or handle with dynamic memories will ask for more memory using the new keyword. Let's say if I want to create an array, and if this array is of integer type, we'll be using something like pointer. So you'll be learning what pointers are in this week, and I hope some of you already learned in the last week as well. And we'll be using the int keyword again. And let's say this is how I would go about asking for 10 blocks of memory, and I'll be storing integers. And this memory is going to come from the dynamic memory. And let's say somewhere here, you'll be given 10 blocks of memory. And 9. And the problem with dynamic memory is dynamic memory does not have variables like how we deal with the regular memory. So instead, what we do is we'll create this special type of variable called pointer and ensure that it points to the beginning of the address. Okay. So when you are implementing the vector class, you will be needing a pointer pointing to the dynamic memory location where all the vector array elements are going to be. And then you'll also be needing two variables, one to know how many elements are there in the vector or how many elements can be accommodated in the vector, and the other to know how many elements are there at this point in the vector. So all these three variables are required as part of the vector class. So this is how dynamic memory allocation stuff happens. And another thing that you will be learning in this week would be a concept called as deep copy. So whenever uh, this part happens, like copy the data from old memory location to new memory, you'll be using a concept called deep copy. So be careful of this concept. And this is a kind of easy concept. You guys will be able to pull it off. So that's all I can say as part of this assignment so far. We'll be dealing with something called as dynamic memory, and dynamic memory doesn't have like the regular variables that we generally go about playing with. So we need a special type of variable called pointers, and this is how we'll be asking for more memory to be created while the program is under execution. And the only thing that we have to take care is that we have to perform something called as deep copy. So if you solve these two aspects of the assignment correctly, you'll be good for the rest of the assignment and you'll solve them pretty quickly. And we took some liberty. That means whatever the regular vector implementation is there in C++, that's kind of slightly different from what we already or what we are going to do in this assignment. And all these three are three types of constructors: vector and vector with an integer value and vector with couple of integer values. So you can see the examples here. So you can create a vector in this way. You can create a vector and you can specify how many elements you want. You can also specify the vector and number of elements and what should be those elements, like kind of default values for those elements. And resize is an operation like where the twice the capacity is going to be allocated. So whatever these two lines of code are there, this is the line, this is the pseudo code or the algorithm that should go into this function called as resize. So whenever the size and capacity values are equal, it should be the size should be increased. And another thing, a user can also ask me, like saying that I want to resize this vector. So if a user is calling the resize function manually, the size of the vector should be doubled. My bad, the capacity of the vector should be doubled. And string to fit at any point, let's say the vector can hold up to 10 elements, which means the capacity of the vector is 10. So let's say I have a vector ARR 0, 1, 2, 3, 4, 5, 7, 8, 9, and I only have 3 elements. So that means capacity has the value of capacity is 10, but size of the vector is only 3. So whenever we call this function shrink to fit, we'll be kind of doing the opposite of resize, where what we will do is we will create a new dynamic array, and the size of this dynamic array is whatever the current size is. So it's going to be 3. So let's say this is new ARR. So new ARR will have only 3 elements, and our job is to again copy these elements 0, 1, and 2. So that means essentially what we are doing in string to fit is we are reducing the capacity to whatever the value of size. So that's the point behind string to fit. So both the functions, resize and string to fit, are there to either increase the capacity, double the capacity, or reduce the capacity such that capacity value is equal to the value of size. Pushback will insert an element at the end. Popback will delete an element at the end of the vector. And the function clear, it removes all the elements in the vector. And size will tell you how many elements are there currently in the vector. And capacity will tell you how many elements can be held inside a vector. This is a Boolean function, and empty is the function name. It tells us whether the vector is empty or not. And print elements, when you call this function, it is expected that it should print all the elements inside the vector. So one of the drawback or a negative, or not a drawback exactly, but one of the key aspects of accessing an array elements, like doing something like ARR of 1 to get the first element in the vector or array. So this sort of accessibility is not there in this assignment. So that's why we have a function called print elements to print all the elements inside the vector. And lastly, we have a destructor. Destructor is a place where we will, delete the memory or delete the dynamically allocated memory. And through the destructor, you'll be learning the usage of this keyword called as delete. So delete will delete the dynamically allocated memory. And remember, it's on the shoulders of a programmer to handle the dynamic part of the memory. So if we are creating that, it's our responsibility to delete it at the end or when we returning out from the program. And important aspects, main.c++ is already provided for you, and whatever the test cases are there on PortGrid, all the test cases you can see under main.c++. And then vector.h is implemented for you. You don't need to modify or change anything, and it's already so you don't need you have to implement the imp.c++. And inside this file, all the functions are blank. So you have to write from scratch all the constructors, functions, and destructors. And here's the instruction for compiling the code. And here are the sample test cases. If you're creating vectors in this way, where you're not giving size, where you're not giving any elements, the size is going to be 0, capacity is going to be 0, and at this point, vector is empty. And while the program is returning back from the main function, whatever the memory is, it will be deallocated. In this case, nothing. And now if you're asking for a vector to be created this way, that means we want a vector where all those 5 elements will be 1. So size and capacity are equal at this point. So if you see, we can query for size and capacity in this manner, and the output of both of them is going to be same. At this point, vector is not empty. And if you're asking for all the elements to be printed out, this is how the output should be. And when you are returning back from the main function, or whatever memory was allocated for these 5 elements, it should be deallocated. And this is an example to show you like how vectors double the capacity. So if I'm creating vector without any parameters, the size of the vector is going to be 0. So at the beginning, both size and capacity are 0. And now if I'm manually asking the vector to be resized, that means at the beginning when capacity is 0, the capacity value will be 1 at the beginning. And I'm not inserting any elements. I'm just demonstrating the usage of resize. So if you're again asking for the vector to be resized, capacity will be doubled. So now capacity will be 2. And again, for the third time, I'm asking for the vector to be resized. This time, capacity will be doubled again, and it's going to be 4. So in this way, whenever you're asking for a vector to be resized, capacity will be doubled. So that's the overall agenda of this assignment. You have been dealing with vectors for the past 3 assignments. So in this assignment, this gives you a chance to thoroughly understand and implement vectors from on our own. So that's all in this video. Hope this is helpful. Thank you.